Solve the following quadratic equation by completing the square. And we are given the quadratic equation defined as x squared minus 10x plus 11 equals 0. So to begin, let's start by recalling how do we complete the square? Voila! So remember that if we have a quadratic expression defined as x squared plus bx equals 0, so specifically where our leading coefficient a is equal to 1, then in order to complete this square, we need to add half of the b coefficient squared to both sides of the equation. And what this does is it forces the perfect square, that square of the binomial. So that's what we're going to do here with this given quadratic expression. So here we go. We are given the quadratic expression x squared minus 10x plus 11 equals 0. Now, again, referencing back to the definition here, notice how this quadratic expression only has x squared plus bx on the left-hand side. So we need to add this 11, subtract this 11 from both sides of the equation to get this quadratic expression in the proper form. So we can see that 11 minus 11 cancels itself out to 0, and we are now left with x squared minus 10x is equal to negative 11. Beautiful! So now that we have our quadratic expression in the proper format, we're ready to complete the square. So our b coefficient in this case is negative 10. So here we go. We are going to add, so we have x squared minus 10x, and we're going to add half of this b coefficient, so minus 10 divided by 2 squared, to both sides. So this is equal to minus 11 plus negative 10 divided by 2 squared. Right, so whatever we do to one side, we must do to both sides. So we can continue with our simplification here. This is x squared minus 10x plus negative 5 squared is equal to negative 11 plus negative 5 squared. So I want you to keep that negative 5 in mind. So simplifying a little bit further, we have x squared minus 10x plus 25 is equal to negative 11 plus negative 5 squared is 25. So notice on the left-hand side here, what we've done is produce the square of a binomial. We can rewrite this in its factored form as x minus 5 times x minus 5. So see how that negative 5 came back in? And this is all equal to, we have negative 11 plus 25, which leaves us with 14. So giving ourselves a little bit more room. Again, we can see now that we have the square of a binomial, x minus 5 times x minus 5. And we can rewrite this as x minus 5 squared is equal to 14. And this is now set up in the perfect format to solve by the square root method. So in other words, we have officially completed the square, and we're ready now to solve by the square root method. So here we go. We are ready to now take this completed square and solve by the square root method. So we are going to take what we found above, and in order to solve for x, we need to remove the square. So we will take the square root of both sides of this equation. So we can see that the square and the square root cancel each other out, leaving us with x minus 5 is equal to plus or minus the square root of 14. Now there are no perfect squares that live within the factors of 14, so that is as simplified as that radical can be. Now, to solve for x, we are going to isolate it by adding 5 to both sides of this expression. And we can see that minus 5 plus 5 cancels itself out to 0, leaving us with x is equal to 5 plus or minus the square root of 14. Which is beautiful. We can leave our answer as such, or if you want, you can separate this out so that we can see the two distinct x solutions. So we could rewrite this as x is equal to 5 plus the square root of 14. And we also see that x is equal to 5 minus the square root of 14. So whichever form you choose, whether you choose to keep this in the compact form, where we have x is equal to 5 plus or minus the square root of 14, or if you separate it out so you can see the two distinct solutions, they are both equivalent and they are both the beautiful final answer.